our task 2 is about bisection method. So we are given a function here and we have to approximate the root of this function. A note is given to you that the function has a discontinuity at x is equal to 0, which means that the function doesn't touch the point of the x-axis where x is equal to 0. That's the y-axis, right? So here you have the graph where at x equal to 0, the function does not touch the x-axis. As you can see from the graph, the function does not touch the x-axis. So for the initial guesses, we have to guess something here itself, both in the negative side, because it doesn't touch the x-axis. So you have to see for two negative values here, you can see that it is crossing the x-axis here, right? So the initial guesses both should be negative, right? Now here let's start working on this. So our initial guesses that we can take is x0, or you can say x upper limit value can be minus 0.5, and if you put in the function minus 0.5, you get the value as minus 1.143, and if you take x lower value as minus 1 and you put that in the function, you will get 0.3679. So you can see for two negative values we have got one negative and one positive value, right? So the graph crosses between these two values, the x-axis. So we can take them as our interval or initial interval. And let's start working now for the first iteration. So here this says calculate the absolute relative approximate error after every iteration starting with the second iteration, not the first. And then we have to conduct 3 iterations and we have to choose appropriate initial guesses. That's because the question already mentions that the function has a discontinuity at x equal to 0, right? Okay, so now here for the first iteration, our interval is minus 0.5 to minus 1. Okay, and we'll find out our x value as the middle value of this two, which is minus 0.5 plus minus 1 divided by 2, and that's equal to minus r. Let's not write that. So here you have minus 0.75 as your answer, and if you put that in the function minus 0.75, you will get the values as minus 0.29847. Okay, now how to choose the next interval, the interval for the second iteration. Many of you get confused here, I have seen that. So what you can do is, to make it easier to look and find out just by looking at it what is your next interval, is write all the values after or you can say write all the function values once you put these x values here, right? So you have here f of minus 0.5, and after that you have f of minus 0.75. So arrange it in order, right? So ascending order, this is the smallest, then bigger, and then you have minus 1. So first you have to take care that you have arranged the numbers of x in ascending order here, and then you write down their values. So here the function with minus 0.5 gives the value minus 1.143. So we have already worked these all out, and then here we have minus 0.298467, and f of minus 1 is 0.3679. So now we'll just have to look where there is a sign change, right? So here it's negative in the first f of minus 0.5, and then again we have a negative f of minus 0.75. So there is no sign change, so we don't take that, we don't take this interval because there is no sign change in this interval, right? Now we'll look at the next one here. So for minus 0.75 you have a negative number, so this is less than 0, and then for minus f of minus 1 you have a positive number which is greater than 0. So there's a sign change here, so we can take this as our second interval, right? Okay, now let's write for the second iteration. So for the second iteration, our interval is minus 0.75 comma minus 1, and then we'll find the mid value of it, which is our x. So xm is equal to minus 0.75 plus minus 1 divided by 2. So we add both the values of the interval and divide it by 2. That gives us here minus 0.875, and then we'll find out the function value at the x value minus 0.875, and that is equal to 0.03963. Okay, so now again we'll write all the function values here. So we'll write for f of minus 0.75, f of minus 0.875, and f of minus 1. So here we'll write them in ascending order here. So first f of minus 0.75, and then we'll have f of minus 0.875, and then we have f of minus 1, right? And then we'll write the values now. So for f of minus 0.75 you have minus 0.298467. For f of minus 0.875 you've got the value is 0.03963, and f of minus 1 is 0.3679. Now again we'll check where we have a sign change, right? So here now we have f of minus 0.75, a negative number, and then for the next one we have f of minus 0.875, a positive number. So there is a sign change right at the beginning. So here we have a negative number less than 0, and here we have a positive number greater than 0. So we can say this is our third interval. But we have to also calculate here the relative approximate error. So let's calculate that one. So we have E of A is equal to the new value of xm, so xm new minus the xm old value, which means the value previous to this, and then we'll divide it by xm new and take the absolute of this and multiply it to 100. So here we have the new value of the xm is minus 0.875 minus the x old value here is minus 0.75. So we have minus 0.75 divided by x new, which is minus 0.875, absolute of this all times 100. This gives us an error percentage of 14.3% in the second iteration. Now let's go to our third iteration. So the third iteration, the interval we have seen here, you got already, which is minus 0.75 comma minus 0.875. Alright, now we'll find out the x sub m, which is equal to minus 0.75 plus minus 0.875 divided by 2, and that gives us the value minus 0.8125. So now we'll find out the absolute relative approximate error, which is, again, I don't want to write the formula, so here we'll take the xm new, which is minus 0.8125 minus the xm old, which is minus 0.875 divided by xm new, which is again 0.8125. Absolute value of this times 100, that gives us 7.69% error. And that's the end of task 2.